Here is a question. We're going to sketching y equals to x squared plus x plus 2 over x minus 1. So this is a rational function again, as I explained in the last month videos. There's a few steps we're going to follow. It's exactly the same step. So that was first step was finding the vertical asymptotes. I'm just going to write the VA, vertical asymptotes, which is the denominator cannot equal to 0, which x minus 1 cannot equal to 0, and therefore x cannot equals to 1. What does that mean? Meaning my vertical asymptotes is x equal to 1. First step. Second step is the finding the horizontal asymptotes. I'm going to just call HA, horizontal asymptotes. So I explained the last video, say the horizontal asymptotes is when the x approach to infinity, very big x value, what is the y approach to? So let's do the same work again. And I'm going to do the same thing as my last video. I'm going to divide by highest power of x. In this question here, again, is x squared. So I'm going to divide by x squared everywhere to make equivalent fractions. So x over x squared plus 2 over x squared over x minus x squared minus 1 over x squared. Right. And then I expect I get my horizontal asymptotes. But I seem to have a problem here. Let's see what's the problem. Here give me 1 plus 1 over x plus 2 over x squared over 1 over x minus 1 over x squared. So which gives me limit x approach to 0, not 0, x approach infinity, yes, okay. Yeah, with this infinity, I will see this part, I'm going to tell you, this part here going to become 0, and this part here also going to become 0. And then my big problem now comes, I'll show you my problem here. My this part here also going to be 0, and my this part here. The numerator becomes 0, it's not a problem, but my denominator now becomes 0. That's a big problem. Looks like I'm going to have 1 over 0. That's a big problem in math. We cannot have denominator equal to 0 here. Here, that's a problem. So what does that mean? It means actually I didn't find my horizontal asymptotes. So there's no horizontal asymptotes. There's no HA. So what does that mean? It means we might have oblique asymptotes. But problem come again. How do we find the oblique asymptotes? Here is the way I'm going to show you. My function was y equals to x squared plus x plus 2 over x minus 1. And I'm going to rewrite a new looking with long divisions. I'm going to write in the normal division identities, which is become a quotient plus a remainder over my divider. Okay, so let's try writing the new way. So let's do the long division here. I have x squared plus x plus 2, and here x minus 1. So I have think of one number multiplied by x here give me x squared. So I will say it's x. and then I multiply x to the x minus 1. So give me x squared minus x. And then I minus these two. So x squared minus x squared give me 0. X minus negative x give me 2x. Then I'll drag the next one down, which is 2. So then I'm going to repeat the same process. So I'm thinking, what times are x again? Give me 2x. So I know it was 2. So plus 2. And then multiply again. So give me 2x minus 2. And the minus again give me 4. Right, so these are my finished my long divisions. And then I'm going to give all this name. Firstly, this is my qx. And then next one, this is my dx. And the next one, this is my remainder, Rx. So I'm going to put all these back into my equation here. So it's become equals to x plus 2 plus my dx is x minus 1. And my Rx is 4. So this is the new looking of my functions. So now let's back to do the questions. So what does this help us is, now you can see when x here approach to infinity again, the whole function, this fraction here is going to approach to 0. So what does that mean? It means when x approach to infinity, this time my y is approached to x plus 2. So this is my oblique asymptotes, which is usually the quotient here. Okay, that's a complicated part. And then the rest, it will be similar to my previous questions. As the next step I'm going to do is finding the x-intercept. So I call third step. Okay, finding the x-intercepts. I let y equal to 0. So I have x squared plus x plus 2 over x minus 1 equal to 0. Remove denominator times x minus 1 each side gives me x squared plus x plus 2 equals to 0. And I'm going to solve these quadratic equations. It's easy for me to solve by quadratic formulas, but before that I'm going to do the discriminant first to determine whether we have the value or not. So delta equals to negative b plus negative b, which is negative 1. B squared, positive 1, yeah, it's positive, b is positive 1, so b squared minus 4 times a is 1 times my c is 2. So I'm having 1 minus 8 equals to negative 7. I have my discriminant less than 0. What does that mean? Actually, there's no solutions for this quadratic equation. What does that mean? Means no x-intercept. Okay, so which means the curve I'm going to sketch in, it wouldn't touch the x-axis. Now the y-intercepts. I'm going to let my x equal to 0. So y would be equals to 0 squared plus 0 plus 2 over 0 minus 1, which is equals to negative 2. So this is my y-intercept, 0 and a negative 2. All right, okay. the next step, I'm going to do derivative for finding the station point. So I call step 4. So my dy dx. Okay, so my y, I'm going to using the new looking is x plus 2 plus 4 over x minus 1. By using this one instead of the original functions here, because it's easy for me derivative. So I'm going to rewrite this into index form 4 of x minus 1 to the power of negative 1. So now ready to derivative. Let's say dy dx is equals to 1 plus 4 times negative 1 times x to the power minus 1 to the power of negative 1 minus 1, which is giving negative 2, and the times 1, that's the channel inside this part derivative, give me 1. And I'm going to tie this up and ready for finding the station point. So it becomes 1 minus 4 over x minus 1 squared. So for station point, I let 1 minus 4 x minus 1 squared equals to 0. Remove denominator again times x minus 1 squared on each side gives me x minus 1 squared minus 4 equals to 0. And this time I'm going to keep my perfect square. Move the 4 on the other side and the square root of both sides give me x minus 1 equals to, please remember, plus minus square root 4, which gives me 2. Therefore, x is equals to 3 or x equals to negative 1. Looks like we're going to have 2 stationary points. With x equal to 3, I'm subbing the 3 into my original functions, give me y equal to 7, and when x equals negative 1, I sub in and give me y equal negative 1. So I'm having 2 stationary points here, and I'm going to test the nature of station point by finding the second derivative. So my second derivative is going to be, going to using my first derivative in the index form. So my first derivative dy dx is equals to 1 minus 4 x minus 1 to the power of negative 2. Then using this one, give me the second derivative is equals to 1 derivative 0, negative 4 times negative 2 going down, and times x minus 1 to the power of negative 2 minus 1, negative 3, times inside the derivative, which is 1 again. And then that's my second derivative. I'm going to tally them up into 8 over x minus 1 to the power of 3. Now, at first x value x equals to 3, my second derivative sub in give me 1, which is positive. What does it mean? It means it concave up, and means I have a minimum turning point at 3 and 7. Yeah, and then at x equals to negative 1, and I'll sub this x value into my second derivative again. It gives me negative 1, which is less than 0, and that means it is concave down at that point, means I have maximum turning point at that point is negative 1 and no negative 1. Okay, I have one each, one minimum and one maximum. Next step, I call it step 5. Finding the point of inflections. Okay, so I let the second derivative equal to 0 to find my possible point of inflections, which is let this one equal to 0. That is 8 over x minus 1, that's my second derivative, equal to 0. Remove my denominator times x minus 1 to the power 3 on each side, but gives me a funny equations. Wow, scary. 8 equals to 0. That's impossible. What does that mean? It means there's no point of inflections. No solution for these equations means no point of inflections. Looks pretty simple, no inflection points. I think I got all my features. I'm going to put all these features together. I summarized everything we have found now. Wow, it's a long process again. So first one was your vertical asymptotes. I'm going to use in red is x equals to 1. Second one is my oblique asymptotes. Because there's no horizontal asymptotes, oblique asymptotes is here. And then the third one is my intercepts, I guess. But I think I don't have my x-intercepts. No x-intercept, meaning I don't need to touch the x-axis. And the y-intercept is here. Okay, so the next thing I'm going to do is stationary points, which is there's two station points, one minimum turning point and one maximum turning point. Okay, and the next one's inflection point, but I know I didn't find it, but you could remember no inflection points. That's also important information you find. I think that's all I have. So I'm going to sketch in the beautiful curve. Can I go here? I'm using a new page. Okay, put in the middle of the page. So that's my x-axis, and that's my y-axis. And origin here. Okay. First one is my vertical asymptotes. Is x equals to 1. So I say this is 1. So here. And the second one is my oblique asymptotes. Y equal to x plus 2. Okay. That was 1 here. Put the one that's here. One y equals to x plus 2 is your oblique asymptotes. So this is a line again. The x-intercept for this line is the negative 2. Y-intercept for this line is positive 2. So this is my oblique asymptotes here. And I'm gonna put this equation on the side for your reference. Okay, good. And then my next one is the intercepts. I think I have no x-intercept, which means I cannot touch the x-axis, but I have my y-intercept is y equal to negative 2. So it's negative 1, negative 2. So I'm gonna make sure I pass through this point. Right, next one is my station point. I remember I have two station points. One is maximum, one is minimum. So my maximum turning point is at negative 1 and a negative 1. So I'm going to put in here, let's say this point. And I'll put the coordinate down, negative 1 and a negative 1. Okay, maximum. And another minimum turning point at 3 and 7. That's 1, 2, 3 here. Let's say 7 is here. I'm gonna make maybe down here. Let's say this is 7 here. So 3 and 7. Then 7. Okay, and then no point of inflections, so it's ready for me to sketching. Don't forget your vertical asymptotes here. Don't touch the vertical asymptote ever, and you approach to oblique asymptotes. So I'm gonna join these 2 points together, and then let's go. So I'm going to do this half first, and then the other half approach to my oblique asymptotes. And the same here. I'm going to minimal turning point here and approach my, oops, don't touch. And I'm gonna extend my vertical asymptote a little bit more to make your curve approach to it. Yeah, done.